Good morning, everyone. All right, let's get this show going. So, not a whole lot of stuff going on with pull requests this week. We've got a couple of new ones. Nothing real huge though. Yeah, I haven't actually looked at real closely at either of these. There's just a new one by Sage for an OSD optimization, and then another one for what looks to be some kind of a heartbeat locking optimization. Beyond that, there's been a couple of different things that were updated. Work's still ongoing with this new object store perf benchmark. I think Igor was doing some testing on it and giving feedback. I think a lot of stuff is actually kind of on hold until Kraken gets released. So yeah, a lot of the kind of more interesting stuff here is kind of waiting on that. So I guess once that's released, hopefully we'll see some movement on this. But for today, at least, there's a fair amount of stuff here that's just kind of waiting. All right, let's see. Okay, there's a couple of different. It looks like a couple topics are being added here for discussion, but I'll just kind of quickly go through the ones I've got then, and then other people can probably talk for more of the time here. So over the past week, we ran RBD on EC overwrite tests, both on spinning disks and NVMe, and looking at both file store and glue store. The kind of general gist of this, the link's in the Etherpad here. If you want to actually look at the graphs, you have to kind of scroll over to the right. But the overall gist of it is that Blue Store actually does really, really well with RBD and EC overwrites for large sequential writes, which is kind of the case that you'd expect this to do the best in, where you've got just big streaming write I/O happening, and it's actually quite fast. And on NVMe, I think it was about twice as fast as 3x replication, and for hard drives, I think it was about 50% faster. So that's the good news. That's kind of a good common use case for RAID anyway, and we're seeing some of the same kind of benefits that you see in those cases. We also see a lot of the same kind of problems. Sequential, well, actually, maybe new problems. Sequential reads are slower, and that makes sense given the way that Ceph works. The primary OSD now has to go fetch all of the chunks from all of the other OSDs that are participating, and it's just generally slower than if you're pulling the the object entirely from the primary. So that's unfortunate, but to be expected. Small random writes are slower, and that also, I mean, makes sense just in the way that this all works. You're doing a lot of extra work. So Blue Store is slower, but maybe tolerably slower. I'm hoping we can make it a little faster than it is right now, but it's definitely slower than replication. File Store is pretty atrocious, to be honest. It's dramatically slower for small random writes versus replication.
So I want to take a second to put this in context. So I think the only number that we should pay much attention to right now is the case where we're overriding a full stripe, because that is looking roughly what it's going to look like sort of going forward. And in the Blue Store case, it's you write a full stripe. It is doing a clone range on all the previously overwritten data. So it's generating a little bit more metadata than we ultimately eventually want to do, but it probably isn't a dramatic difference. File store is never, ever going to look any good for the EC overrides because it's literally copying, reading data, and then writing it somewhere else, and then overwriting it. It's just not designed to be able to handle this. So I think we can ignore that. The plan for between now and Luminous is to make the case where we're doing small writes that are smaller than an entire stripe more efficient by hopefully updating only some of the shards in the stripe and then making peering clever enough to handle the case where some of the shards saw some updates and some of them some other updates, and the logs get sort of merged in order.
There's pretty much no way that part makes it into Luminous. The goal for Luminous is to get the goal for Luminous is to get the checksumming fixed, and start the refactor needed to do that stuff.
Okay. And hopefully make Blue Store possibly have Blue Store do the rollback thing so that its metadata management in that for that clone case or whatever is more efficient. Although even then, I'll have to see. I'm not sure if that's going to be the top priority either. Okay, so in that case, we really should be looking at the full stripe write case as, I don't know. I mean, can we just make the structure the stripes so that they're 4K? I guess we could do that. In which case, the problem mostly goes away. Sort of over.
I mean, they probably are. It defaults to pretty small ones right now. Mark, what did you set them to?
I just left them at default, so whatever currently the default is.
I also find out what that worked out to be. It might not have been 4K. Maybe we made it like 16K.
Okay. I think the only big question that's raised for me is you were showing that the sequential writes were really fast, which is to be expected because we're writing less data. But it shouldn't be any different than the old EC. Like if you're doing sequential writes with pre-Joule or whatever you Joule.
This is RBD.
Yeah, even so. I guess you can't really do the comparison quite right, but
no. But yeah. I mean, what would be the point of comparing it to old EC, I guess?
To find out whether we accidentally introduced a bug.
If we accidentally did what now?
It shouldn't be faster. If it is, that means there's a bug.
No, I'm not saying it is faster than that, but it is faster than replication, which is, I think, good.
But it should be. We should see the same. We should be the same effect with Ratus bench on an EC pool with Joule code.
We always did, right?
I assume so. We should.
I think
it should be the same effect, I guess. Mark, I mean, if you can verify that on the same cluster or whatever.
Yeah. From what I recall, back in the early days when we introduced EC, performance for an EC pool with large sequential writes was somewhere between 2x and 3x. And here we might be a little bit faster than that, but there's been a lot of code changes since then. So, I mean, it could just in general be that we have more headroom than we used to.
It sounds like everything is as it should be there then. So
yeah, I think so. I mean, these results seem very reasonable to me in terms of what I would expect to see, right? I mean, we're doing really well on sequential writes. We're doing kind of crappy on sequential reads, which makes sense given our architecture. We're not doing well with 4K random writes with file store, which from what you guys are saying sounds very correct too. So I think I don't know. I don't see anything here that seems off. If that, I mean, is there anything here that you guys think is unexpected?
Nope.
Hi, Mark. I was
nope,
doing,
I think the only...
Sorry, Sage.
Go ahead.
I've been doing a little bit of testing as well, Mark, and what I found is sequential reads at lower Q depths with the EC actually shows slightly better performance than replicated pools. I think it's the difference between if you're sort of splitting the chunk sizes over striped EC rather than doing 4 meg reads in replica pool. It's pretty slightly more efficient, but if you're saturating the disks, it would sort of get worse.
Sure. So if you're at low IO depths, you don't have very much concurrency. So maybe by doing the EC reads, you're spreading your IOs across more devices.
Yeah, like so if you've got like like 4 shards, you're probably doing like 1 meg read IOs to the disk. So they'll be returning faster than a 4 meg IO.
Okay. Yeah, I can buy that. Cool. I think the only other thing I had to mention on here was that there was one commit a while back that was kind of discovered while we were doing this testing that it looks like it may hurt file store replication performance in some cases. So we are looking into that. But if anyone sees any regressions in recent master with file store and replication, specifically with partial overwrites or potentially random writes of larger sizes, and maybe like the 1 megabyte to 2 megabyte range, is quite likely that it's this. So we are tracking that down now. I guess the only other thing I'll mention is that we have started doing some BlueStore with Zettascale testing at Red Hat. It just started yesterday, so we're still getting results and still figuring out how to tune it. We'll have more to come hopefully next week. But for now, I'll just leave it at that. All right, let's see. Who added fast dispatch optimizations?
That was me.
Okay, fantastic.
Yeah. So after looking at going through Reddy's 2 stars breakdown of latency last week, I just started to focus on just that first handoff between the fast dispatch thread, putting things into the queue and looking at all the things that we're doing there that we could hopefully not do. And there are a bunch of low-hanging fruit. That one was the first one. There's the pull request that you linked at the top that the get xmap reserved is like doing it's banging on a mutex, it's doing a memory allocation, an STL map that usually gets removed and then re-added on every single app. Bunch of like just kind of stupid stuff. So that pull request tries to address that. The next thing is that it allocates or right before I forget, it allocates the op request, which is fine. But then I noticed that the op request is all using shared pointers. And so I actually wanted to change the queue that it pushes it on it pushes it onto the sessions queue, and then it immediately goes and processes everything in that queue and usually pops it back off. So I wanted to make that an intrusive list so that there's no additional memory allocation there. But in order to do that, we need to change the tracked op to be a intrusive pointers. The ref use intrusive pointers instead of shared pointer. And so I'm like 2/3 of the way through just fixing that. There's some annoying issues in the MDS switching the tracked app to be rough cannon because of multiple inheritance and the base class used in the MDS is different and whatever. It's trying to sort that out. But I'm still working through that. But I think once what I'm hoping is that we can make those changes and then rerun that same latency test and actually see a difference, a measurable difference in that handoff, the amount of time we're actually spending in half this fast dispatch. Maybe that's optimistic. I don't have a good sense of the order of magnitude, the amount of time that those operations are taking or wasting. But it seemed like a good place to start because all the stuff that's done in the OSD, there's some larger refactoring we want to do there. So that fast dispatch piece seems important. Any comments on that? Does that seem reasonable?
That seems good to me.
Yeah. Okay.
Yeah, I was always surprised that that way I was doing the map reservation didn't show up as something to fix sooner.
Yeah, I mean, I'm not sure that that's where the time is actually being spent, but you kind of need a pretty detailed profile to tell, but it's one of the obvious things that's happening, I guess, in that path. So
how much time is it, and how much is it compared to the actual total processing time?
I don't know. I mean, we're going by the I was just looking at this path because of the total breakdown that Tushar did. It was, I think, 50 microseconds on that amount of, roughly that amount of time that is total spent in fast dispatch.
Mm-hmm. Right, so it's 50 microseconds out of what's the total number?
For a total op, it's like 500 something. I don't know, somewhere in there.
10%.
Yeah.
Right.
Yeah.
Yeah.
Yep. But it's sort of a narrow thing that in theory should be like super fast. Like we're not doing any real work. It should just be, the only thing we really should have to do is allocate the structure, figure out what queue it belongs on, and put it on that queue, and then go away.
Yeah, it sounds like a low-hanging fruit, but
yeah,
test should be run on the same exact version that run before, just with the fixes applied. So
yeah,
something.
Yeah. So the second thing I just want to talk about really quick. Ready open to pull requests with the trace requests or the trace points. There are two pieces. There's a really simple one that just lets you put a macro in a function that will then add an entry exit instrumentation with LTT&G trace points for that function. That one seems like a no-brainer. The other one is a little bit trickier because it annotates it with the object ID. So what I'm thinking is that we should merge the pull requests that just define those macros into master. And then what I'm less sure about is whether we should merge all of the actual functions that were annotated in. I'm thinking probably because he added a CMake define that lets you turn them all, compile them in or out. So they'll just go away. They won't compile anything by default. The only tricky piece is that for the object annotation, there's a bunch of extra fields that have to get added to various structures so that we have the object name to put in the trace point. So there's a little bit of overhead. There's some like if-def stuff that gets sprinkled through the code in order to make that work. But it seems like just carrying these in master is going to make it easiest we can adjust that over time as far as the code paths that we're interested in.
I agree.
And instead of trying to have something that we keep rebasing. Okay.
Yeah, this is better.
All right.
So, I mean, we can if-def out the extra fields, right? That was part of the thing.
Yeah, it's a CMake -D whatever that enables those trace points that makes them built in.
I mean, not just the trace points, but the fields.
The what's?
The fields where we added the object ID to a bunch of stuff.
Yep. Perfect. Yeah, those are guarded by the if-defs too.
Seems like a no-brainer. I don't think it should go into Kraken though.
No. Yep. Okay. But all right. So I'll put it on my list to just rebase those patches and break them into the separate pieces so we can separate them out. But all right. That's all I have there. I'll keep working on the op tracker cleanup. It's mostly, I think once I fix the metadata server, then that's a little tedious. So.
Sage, can you get me? So this is Tushar. Like the different part of the trace, the breakdown was basically, it also showed like some network bottlenecks, right? So as in bottlenecks at the messenger and the network layer. So I started looking at the latest, the DPDK based async, the front end. There's some challenges building that on the master right now, so I've got the request coming up here pretty soon. But yeah, that's something we are actively looking at also, and we'll see if we can next time maybe we can present a breakdown with the DPDKs and front end applied.
Okay. Yeah, it would be interesting to see what the just get a side-by-side test and see what the delta is between just regular TCP and the DPDK. So we have an idea too how much we're going to get. Like, is it tens of microseconds? Is it approaching? I seem to recall that we thought it was in the neighborhood of like 40 or 50 microseconds that was going to give us for overall, but I don't quite remember.
Was it for IO? For IO, like on a single QDEC? Was the improvement on a single IO on the QDEC kind of estimate?
I'm sorry. Is it just me, or is the audio? I think my audio is all messed up. But
yeah. Okay. Yeah. No problems.
I was actually having a little trouble hearing Tushar as well, so it might be a combination of multiple audios screwing up.
Okay. Maybe you can blame Blue Jeans today.
Yeah.
Yeah. So, yeah. Any case, yes, it would be great to see that that comparison as the next step. I guess the one other thing I'll mention is my understanding is that the Mellanox folks are continuing their work on RDMA. They're primarily looking at the RDMA backend for async messenger right now, and that they're still working with the X-Guy, Hamai's team, on that. But I think that's probably a good path forward, because it means that all of the protocol logic is going to be the same across RDMA and TCP and DPDK, whatever. So transport part is sort of separated out, which will be particularly important when we do Messenger v2, hopefully during this next cycle. That'll add encryption and all the other stuff. So, yeah.
If there isn't anything else, if people are open to it, I was wondering if, since we have everyone here, it would be at all interesting to discuss Igor's proposal on the mailing list regarding
right.
Store.
Yeah. Yeah, I'm sympathetic, but I'm not sure I'm ready to give up yet. I don't know. There's the nice thing about using an existing key value database is that we sort of avoid this huge pile of stuff to maintain. It's easy to imagine that we can do way better if we're doing, like, for the sequential time series stuff for PG log entries. We could imagine building some sort of pretty simple layout that works way better, but it gets ugly pretty quickly when non-trivial, because you have to also deal with the case where you're rolling back logs and you're removing them from the front. You're not always just printing them from the back. You might remove a sequence of them entirely for PG and then reinsert them, yada yada. And it's attractive to have a general key value interface that can support all those operations, but is sort of optimized for your particular workload. as opposed to having to reinvent the whole thing for each of those sort of scenarios. But I think
I think you're either gonna. If you use something off the shelf, you're going to find that there's a gap from what could be done with something custom, and you're going to pay that price. And that's what you're looking at, and something that's custom designed ultimately will do better, but it's a lot of work.
Yep.
Well, it's also the case that needs to be the best bang for your effort buck, right? What do you not do if you're building a custom value?
Of course. I mean, it's an ROI issue.
Yeah. Yeah.
Is the proposal that he wants to change the whole thing to use some custom interface, or just that he wants to switch PG log entries over to do something with those?
Well, Igor is here. Maybe we should ask him.
Well, actually, I was trying to reduce the database traffic for node metadata primarily. It seems pretty strange for me that for 4K writes, we actually have database traffic similar to the one performed to block device, or even higher. And so I suppose it's that database is not intended for such a traffic, and we can never gain the same performance as block device. So the idea was to reduce that as much as possible. So I'm not. I don't want to get rid of KV at all, but to store just some indexes there and most of data to store to block device.
Yeah, that might make that sort of partial change might be something we should consider. I think Alan has a good point that the workload is randomly distributed across the object namespace, and so when we're doing these sort of big updates in the object space namespace, we're giving the KV backend sort of a worst case workload.
Well, for rocks, that's correct.
Yeah.
I mean, your problem is you've got two endpoints of the spectrum in terms of behavior. You've got PG logs and PG infos, and that are essentially sequential, and then you've got something that's basically random. I think you can handle both, but you're not going to find an algorithm for both. What you have to do is to create essentially multiple algorithms that have the same transactional layer on top of them, and that's not out there. Now, if you go look at what the Zetascale guys have done, they started from sort of the opposite end of the spectrum of rocks with a B tree, which handles the random stuff pretty well, but is terrible on all the sequential stuff. And then what they did was that they added some specialized behavior into there to deal with that, and have improved the, if you count, basically the right amp, you have much better characteristics. The unfortunate issue is if you look at this from a right amp perspective, with rocks, what you have is sort of one, forget the data. If you just look at the metadata, you got one write plus whatever your compaction overhead is. Whereas with Zetascale, because of the way the history of the code, the best you can do is actually two writes. Okay, but you don't get the compaction overhead. I mean, you do have some tree splitting overhead and stuff like that. Okay, so you end up with 2.25, 2.5 as the number, as the metadata write amp. So for really small volumes, rocks is going to win, but as the volume size gets larger and larger, it crosses over. And we're seeing that crossover, in the sort of low double-digit gigabytes range.
Wait a minute, hang on. Igor, is the core complaint that we can't be as efficient as a block device if we're having to do a metadata update for every block update? Is that the crux of your concern?
Yeah, yeah.
Okay, so what if the OSD didn't need to update the object info for simple writes?
We still have to update the extent map, which is stored in the O node. It helps a little bit. We could restructure the key slightly, but only slightly, I think.
I mean, what if? I mean, in the common case where you already have an allocated extent to this.
We're still updating a checksum, right?
Okay.
Yeah, I think you're still in
write, so.
Yeah, you're still in copy on write mode, and I think that's, by the way, a really good thing that we're not taking as much advantage of as I think we will be in the future.
Then I think the complaint about the key value store isn't really the point. Even if you did something custom, you're still going to have to do these updates. I think it's a pretty good argument against RocksDB, but I don't think it's an argument against doing something custom or doing something custom.
Well, if the argument is metadata versus no metadata, I agree. That's a completely different argument. But once you get metadata, then the question becomes, how do you structure the metadata? And the KV interface has a bunch of pluses and minuses.
There aren't that many fundamental minuses. Is what I'm saying. What I've heard so far is that there is metadata traffic, and I agree with that. But other than the basic concept of custom is always faster, I don't have to hear anything concrete.
Yeah, I mean, I think once you say you have metadata with a certain set of characteristics, and then you ask yourself what's sort of the optimal. A lot of it looks a lot like KV. I have the screed that I published. I have issues about the KV interface itself from a performance perspective, CPU performance and complexity wise. But that's sort of orthogonal to the other issue that we're dealing with.
I mean, I guess you could structure your extent structures more like the way XFS does with fixed delegation groups close to the extent that wouldn't require a key lookup. But
the issues with the key value interface, just the value-based semantics, first of all, are painful. It forces you to have small objects, and instead of having what ought to be a large object passed by reference, we have to sort of manually break the thing up into a bunch of small objects, which is what we just spent 4 or 5 months doing. And the reality is that work is an awful lot like the space management stuff that we're supposed to be getting automatically with a key value store.
Okay.
I'm not against it. I'm just saying we're paying a price for it. Okay. And that price is high. Once you push the other stuff out of the way, you're paying a lot of CPU for the simplicity of the KV interface. You gain some time. There's no doubt about that.
Yeah, I mean, I guess what I'm wondering is if we should consider some other backends here instead of RocksDB. So the ones that come to mind are WireTiger, which I know has a bunch of different storage drivers. They have like if I remember correctly, they have a B-tree one, and they have like a LSM one, and they have a logging one. I just remember they had multiples. So that might be one possibility. What I'm not sure is if they have, if they're sort of unified, so you can have a single transaction that.
If they had a single transaction that you could select the algorithm on a per key family basis, that would be optimal.
Exactly.
Okay.
So that's one question to answer. There's another one too. That's TokuDB. That I think was gobbled up by Percona. So now it's called Percoma FT. It's their fractal tree thing. One of the nice things there is that they do range deletes, which RocksDB doesn't currently do, although it certainly could if they just implemented it. But I'm not sure if they have. I think the behavior probably is going to be pretty similar to LSM.
I doubt that range deletes is going to make life significantly.
No.
You're going to compensate for an LSM.
Yeah, well, I think the range deletes might help with the log data sort of.
Well,
sideways,
yeah, sure. But if you're LSM, you've already sort of fundamentally addressed that issue. made it pretty efficient. What you're doing is optimizing something that's already pretty efficient and ignoring the thing that's killing you.
Yeah.
So LSM is just is not going to cut it. Period. For this use case.
Well, I mean, there's also, I mean, we could look at just like pure B-tree ones, like Berkeley DB, or
well, I think we've got Zetascale where it is. Okay, I mean,
right.
I think that my analysis when I looked at Zetascale is, like I said, that we're getting a write amp of 2.5 to 2.25 for batched transactions, and if I had a green piece of paper, I could get that down to probably 1.5 or something like that. Okay. To 2, or reduce the batch size, and keep the write amp the same. But none of that addresses the interface issues, which is the inefficiency of scanning things that are nearly adjacent, the lack of reference semantics, forcing you to fracture large objects, which are frankly significant performance. The other issue that frankly that we haven't even grappled with yet, that you're going to find you're paying a lot of energy for later on, is the fact that all of these databases are thread synchronous in their read faults. So ultimately you're paying a lot of extra context switching for that. Which that frankly, when it's all said and done, is going to lard up the path links for a transaction. I mean, if you really want to get into the CPU efficient with this, you're going to have to abandon all that code anyways, because there isn't anybody out there that I've seen that has a run to completion interrupt style KV implementation. They're all thread based. And fundamentally, on Flash, you basically thrown a decent chunk of your performance out the window just by doing that.
Yep.
So to get that back, you'd have to rewrite the OSD. All of it. I mean, well, maybe not all of it, but you'd have to rewrite all of that.
That's the purpose of the larger refactor we want to do during the next cycle.
Well, I'm happy to dig in with that. I think the implications for that are pretty large.
Yeah.
I'll send you an email with the documentation I had from the CDM last year.
Yeah. Well, I'm just saying that this issue, intimately ties up with all of that. I mean, the reality is that
you're saying that even if we do that, the key value interfaces aren't going to let us exploit that. We'll always block on their threads, and that won't be good. Okay.
Well, I suspect if you take a KV interface, somebody like a Zetascale or a ROX that's thread based, you could probably do better with a user space thread switching and create your sort of little miniature simulated threading environment that's not as good as a fully rewritten asynchronous, run to completion interface. But you're going to have to simulate a threaded environment for these guys, but without the overhead of the kernel switch context, which is pretty heavy. I think you could actually do that. You won't be quite as efficient, but the delta might be reasonably small. So you're going to end up having to do that. And of course, that's going to mean recreating a certain amount of lock synchronization code and IO code. I don't think that's a huge deal. It's a week or two's work, maybe 3 or 4 by the time it's said and done.
Yeah, I think that's more work than you're saying it is.
Yeah, that's quite possible. Okay. I've personally done one of those myself, so I kind of know where the bodies are buried. But yeah, you're probably right. It's probably more like 2 months to 3 months total time for one person just to hammer out all the bugs.
It's also going to be a fun little portability nightmare.
Well, it tends to ripple through into all sorts of odd places. Things like your debug output, your fundamental mouse, all sorts of things, assumptions that you've made, end up having to be revisited.
I mean, if we wanted to seriously think about this, then the right answer, I think, would be not so much to talk about the interface or not so much to talk about the on-disk format, but write down the interface you'd like to see the database have. Because one way or another, we still want an abstraction there, right?
Oh, agreed. I agree with you.
It might be worthwhile writing down what that might look like. That would give us something concrete to talk about.
Yeah.
Well, yeah, I think this is an interesting discussion for another day. The reality is we are where we are with BlueStore, and it sits in a code base, and if going back to Sam's point about where do you spend your energy, I would, rather than throwing down, several man years right now on tearing up the OSD and rethinking it from scratch, I'd go spend a little bit of time.
We have to do that part anyway.
Oh, I understand. Okay. But I'm saying I'd like to see the partial EC overwrite stuff accelerated.
That's one of the reasons we have to do it.
Okay. Well,
one of the things that refactor gets us is reworking. Right now, the OSD knows about a bunch of metadata that it's not allowed to know about if we're doing a partial EC overwrite. Bluntly, it's much like the partial EC overwrites is very difficult.
I don't disagree with you. I'm just saying, bang for the buck. That I think is going to yield a lot more. I mean, I'll be honest. I just sent an email to Sage. I'm concerned that from my perspective, I'm not sure we haven't done the equivalent of essentially crippling that feature to the point where it's actually no more useful than it is in the Joule release.
It's not. The purpose of this release is to have this code in the code base so it stabilizes.
Well, I understand that, okay, but we're not on a trajectory to have it fixed in Luminous, which was
it'll be slow but stable in Luminous, right?
I understand that, but in other words, previous statement is it's not really any more effective than it is in Joule in Luminous. Okay, you'll be able to run
probably
correct. Okay,
but there are other users for whom it is useful.
I'm sure that's true, and that's that decision will have potentially has ramifications for me that I have to go figure out. And but if I would put that higher on my list of things than a rewrite of the OSD. You're saying that they're coupled together. I'd like to explore that in more detail. I doubt if this is the venue to do that.
The hardest part of doing the refactor is reworking DUOP, which I have to do anyway to fix writing to only one shard.
Well, yeah, I understand that. I'm just saying that I think we were briefly discussing restructuring the OSD into more of a run to completion model, or some user space threading to sort of simulate that for at least a portion of that. And I heard a statement earlier
in terms of futures because also need. I was going to rework it in terms of futures, which we have to do anyway in order to support reads on erasure coded pools from object classes, which we also need as part of the greater feature if we want to actually use erasure coded pools for all of this stuff.
Mm-hmm.
There's no way to do this in an ad hoc fashion without making the OSD entirely incomprehensible.
Well, okay, that presupposes it's not now. You might get some debate on that.
Yeah, Alan, what I'm telling you is that what it would do would make what it is now pleasant by comparison. You wouldn't even be able to trust most of the fields coming out of the object context. It would be unpleasant.
Well, like I said, I don't think this is the venue to get into details, and I'm probably not the person to have that argument. since I don't have the knowledge that's necessary to have that argument. I was trying to make a different point, okay, which was that
your point is that we can perhaps put more effort behind that and accelerate it. I'm telling you that that's going to take a certain amount of time no matter what. So it's probably worth doing other stuff in parallel.
Well, yeah. I mean, in a world, I mean, the idea that we could start a longer term project to rebuild large portions of the OSD in a fashion that is more consonant with the hardware platforms of today and tomorrow, I think makes a lot of sense. I'm looking at issues that are more shorter oriented than that.
Alan, from your perspective, what is the best bang for the buck that we can do right now that you can take back and will be positively received with your management or whatever?
Well, I'm.
You mentioned bang for the buck and not doing this, right? So what is it? What are the alternatives?
Well, I'm not, okay. So I'm not sure that I have the information in hand to be able to offer that right now.
Okay.
Okay. I mean, I think that answering that question, I think, requires a certain set of synchronization amongst the participants on a list of things like estimates of available manpower, estimates of the costs of potential alternatives. I think if you aren't in agreement on what those are, then the preferred path becomes more about your disagreement on the numbers than it is a statement of the value of them, if you know what I mean.
From my own perspective here, which is not necessarily a great one since I don't really know that much about what the storage industry as a whole sees as really huge issues right now. It seems to me that the stuff that Sage is doing right now with basically all of the messenger work and looking at some of these trace point analysis is really good. I think that's one of the things we need to be doing. I think looking at BlueStore and any way possible to reduce the amount of metadata there is really good. And or looking at ways to reduce write amp and whatever key value store we end up choosing is really good.
Well, let's be a little careful, okay? I think that's actually a downstream effect of what you're really trying to optimize for under a set of assumptions that I would question.
Okay.
Yes, I think less metadata is always better. It's always better for everyone. Okay, but it's the value of it is different in different environments. The costs of it are different, and may find out that they're an epsilon. So I think the bigger issues to deal with are to ask the question, given the structure of BlueStore as we have it today, what's the best that we can get it to be? I'll be honest, the changing back ends at this point, is something that will take a long time.
Are you specifically mean KB backends, or are you talking about?
Mm-hmm.
Okay.
Yeah, I mean, let's put it this way. I mean, you just put out the Kraken release.
Well,
you're done.
Not yet.
Well, okay.
Close.
The people are expecting it in their Christmas basket. Now you can undo that, okay? And there'll be a certain amount of depending on how much you undo that. If you undo that by a month, if you undo that by a year, you're going to get some egg on your face, okay? That's and I think before and Mark, I take your question as me stating our preference of which of the various options to go take. And what I'm saying is I think until we agree on what the options are, there's no way to answer that question.
Yeah.
Because changing the KV backend, is not, so first of all, you don't want to get yourself back into the boat that you're in now with rocks, which, happened because there was there wasn't enough sort of research on connecting the abstract model to the physical implementation to see whether or not that implementation was going to be good enough. So before we, so having basically, took a risk and rolled the dice and coming up, less than you wanted, I don't think you want to repeat that exercise. So before you'd be even really ready to switch to some other theoretical KV backend, I think you've got a fair amount of work, weeks of work, understanding how it works and measuring it, across a couple of different scenarios, so that you don't just find yourself right back here 3, 4, 5 months from now.
Well, there's a little bit of with RocksDB, I think we have to be a little bit careful there too, in that we didn't really know what we would see with RocksDB until we tried it, right? I mean, there was no, I don't want to say there was no way, but it would be very difficult to guess from the very beginning that RocksDB would necessarily do badly. And it's done much better than, say, LevelDB would have done. I will very strongly maintain that. Is it possible that we can improve RocksDB?
Actually, I think you have to be careful how you state that. I think the only thing you could really state is that the stalls during compaction, that RocksDB does a better job than LevelDB does. Okay, if you're just let's for the moment assume that you could take LevelDB and tune it in a way or decide that the stalls were irrelevant for whatever reason. I'm not sure you'd see it perform a heck of a lot better.
Yes, that's probably very true. The stalls are that.
I agree. Rocks has improved the stalls, okay, but all the rest of the fancy stuff in Rocks is of questionable utility to this situation.
Yep.
So I think the problem is I think you've got the classic tactical strategic divide here, and your tactical choices are constrained. I don't think it takes long to make a tactical decision because the choices are constrained. It's just enumerate the choices and figure out if there's some work to do to augment the knowledge base. It's probably small. The strategic vector is a whole different issue, and let's not conflate the two right now. I mean, I think that and clearly everybody is building the conclusion that says you're going to need to rebuild the OSD, and when you do that, you're probably going to have to you're going to revisit this issue of what's the storage engine abstraction, not just the interface to it, which I think has issues, but also the semantic behavior of it, etc. You may choose expediency there and take something that's less optimal to market sooner, or you may choose to say no. this is an area where my fundamental performance is, and I need something that's pretty optimal. And unfortunately, there isn't a thing out there that does what I want. I don't know what that is. I'm not saying one or the other. I think that the choices in the strategic sense are different than the choices in the tactical sense.
Yeah, I agree with that.
I think you mentioned a couple of other key value stores. If it's certainly worth a day or two's reading through the documentation on them to see if they seem to offer this kind of behavior specific. We're looking for essentially a palette of behavior specific stuff. We'd like to be able to say these keys, should have this kind of engine, and these keys should have that kind of engine. I don't think it'll take very long looking at the documentation to find out whether this alternative engine gets you there. I know, for example, Berkeley DB does not. It's strictly a B tree. I don't think it's got anything else in there.
Yeah.
Okay. I'm not as familiar with the others. But this is something that tactically in a day or two can be answered. And if the answer to that is no, they don't, then I think they're out of the running. And you're back to where we are today, which is you really only got two choices. You got ROX and Zettascale, and they're both they're both suffering from the behaviors that we see. I think we're certainly seeing numbers that suggest Zettascale is better than ROX. Hopefully you're going to get to see that with the code in your environment here shortly, and we've noticed some very interesting things as you change the performance levels of the hardware that, oddly enough, seems to have a major impact on it. We've got about 3 different sets of hardware, all flash, in our repertoire, and the optimal choice here is not what you would expect on some of them, oddly enough. The other thing here is we haven't even, I don't know that anybody, I don't know how much work has been done on the hard drive side, which matters here.
On the hard drive side, at least in the things that I've done, the metadata load seems to be low enough that we're more dominated by the actual I/O than what's going on inside RocksDB or potentially Zettascale. I don't know there, but at least with RocksDB, it seems like we're not seeing a lot of the data movement between different levels and overhead there that we see with the fast writes that NVMe are capable of.
Well, I mean, the costs for compaction are radically different on a hard drive than they are on flash. And that's going to change your view of the critical nature and what's good performance and not, et cetera. I agree with that. I guess I'm probably more interested in the flash over hard drive model.
Yes.
That, I think that's really the sweet spot. The all hard drive model, I think you'll see it. I'm not interested. I'm not terribly worried about optimizing for it. And I'll reserve the right to change that opinion when some sales deal drops in my lap. But until then, okay, I'm not terribly worried about it. I think I think it's going to underperform your existing back end. Maybe
what will underperform?
Blue Store on all rotating will underperform File Store on all rotating for certainly in the block use case and potentially in others.
It's typically quite a bit faster in almost all cases, or at least it has been in the past.
Well, okay. Well, okay.
Yeah. The concern is when you have small, the expectation, my expectation is that when we have lots of small I/O and we fragment heavily and we have a metadata explosion, then the worst case could be slower. But I agree. I'm mostly concerned with making like a large object storage workloads work well on all disks, because I think that's where they're going to be used. And I'm less interested about optimizing for, RBD random IOs, 4K random IOs, whatever.
Right.
In a spinning.
No, I agree with that. Okay, and and as far as the OSD, to me it's the hybrid environment. At this point, a small amount of flash over rotating isn't is pretty cost effective, and likely more so going forward. But I think the reality, I'll be honest with you, I think you got what you got. Okay, if somebody could pull another KV store with the right characteristics out of their hat and drop it in, okay. If for example Berkeley DB, or one of these off-the-shelf KV stores had exactly what you needed, okay, then you could probably drop it in a few weeks. And life would get better. I don't know how much better. I'm not sure it's going to do a lot better than what we're seeing with Zetascale. Okay. And
all of these, Alan, all of these are open source, right? It might be that maybe we need to be thinking about actually going in and modifying some of these.
Okay, but that my point is that I'm not saying that that's not worthy of consideration, but that's not a tactical choice. That's a strategic choice. That's not going to happen for Luminous. Okay, it's not going to happen for So you either have to stay the course with what you've got in front of you as Blue Store, and that's going to show up in Luminous as Blue Store with the characteristics that it has. Okay, or because let's remember, there's still a lot of work left in Blue Store. It ain't done by any stretch of the imagination. We haven't spent a lot of energy on the dynamics yet, guys. Okay, we haven't really explored a lot of the performance space either. Not to mention all the other little ugly issues about getting storage code into production. So, if we're lucky, we're 70% of the way there, 80% of the way there. If we're unlucky, we're 50% of the way there. But setting that aside for the moment, you're at a crux where I think the strategic choice in front of you is it's either Blue Store as we basically know it today, or it's the Blue Store project is hitting the reset button.
Yeah, I think we need to do. I don't think we can afford that. I think I think that path is actually Blue Store is as it is today, and post Luminous we write Green Store or whatever the hell.
I think post Luminous, I don't think that. Well, I think you can rebuild the OSD. Okay, because
and at that point we'll have a better.
Yeah, because the issue you got to be careful about, is sort of the Amdahl's law issue, which is even if you had a Green Store that was itself significantly faster, within the husk of the OSD, with the RDMA and the memory footprint and all of the other issues that we know, okay, so it picks up another 20 or 30%. Big deal. It's not going to pick up an order of magnitude. Because even if the OSD is, even if the object store interface is infinitely fast, you don't actually go very fast.
No, that's what I'm saying though. It's not going to within the current framework of the OSD. Then I don't think there's any point in doing a rewrite of re-architecturing Blue Store, which is why I think we should continue with the current path and continue looking at how we can improve the key value backend. But after doing that rewrite, features-based rewrite of the OSD guts, I think then we'll know more about what interface would be more optimal, and we can figure out whether we can either morph BlueStore into that, or we have to do something that's fundamentally different.
Yeah, I mean, I think when you redo the OSD, you're going to redo the communications interface in order to do something that is deployable at scale with RDMA. Okay, and the way that memory gets managed in an RDMA environment will permeate its way through the OSD. I mean, your good friend, the buffer list, might not look like it is today when you're done, right at the start. That in and of itself is liable to be the thing that forces you to jettison the existing code base. And and my guess is the details of the object store equivalent interface in that world are a small part of the problem, not a big part of it. And I think that's a great thing, but I think I think you got to realize is that's 20 man years of work to pull all that together, and probably 2 to 3 wall years of a dedicated team.
That's why I don't think we should get ahead of ourselves right now.
Yes,
I think
exactly.
The step one is
and that dream needs to be backed by corporate entities that believe that. Yeah, exactly. Okay. So I'll be honest with you. This is the concern that I was a little expressing with Sam, which is we're on a trajectory to have erasure coded overwrites. And the backing off of that now, because the world has to be rebuilt to do that, is a major issue for me. And that's maybe I hadn't heard it before, and I should have heard it. Okay, but that's a real problem for us. I mean, we were focusing on using Ceph for blocks on Flash, and basically what we're saying now is that there's no erasure coding on blocks, in the pipeline.
Yeah, I mean that's
that's what Sam said.
It's not the whole world we're rewriting. It's a big piece of it.
Well,
and
okay.
It's not that there's no erasure coding. It's slower, but we're out of time. I don't want to keep repeating the same thing here, but
right.
I understand your point. There's no easy answer, so maybe we can follow up offline.
Yeah, let's do that.
Okay.
Can we do it on Ceph-Devel though, so that we make sure that the conversation is public for everyone?
Sure.
Cool. All right, guys. Let's wrap it up this week, and I'm sure we will continue next week. So have a great week, guys.
Yes.
Thank you, bye.